Today we'll learn limit of a linear function, limit of a polynomial function, and limit of a rational function. So let's start with limit of a linear function. So limit of a linear function, let's say we have a linear function f of x equal bx plus c, right? Here, remember b, c, all of them are real number, okay? So now if x approaching to a, f of x, limit x approaching to a of f of x is going to be simply f of a. Here a is also real number. What does it mean? Just we have to plug in a values in f function. Here I wrote it down. Instead of x, we wrote it down a and plus c, right? Let's do a example and do an example that will explain our concept. So let's say we had an example f of x equal 3x plus 15, right? This is a linear function. So let's say we limit x approaching to, let's say 2, f of x is gonna be simply f of 2. By the definition, linear function definition we just plug in 2 values. So that's mean we have to plug in 2 in here. So we have 3 times 2 plus 15, which is 6 plus 15, which is 21. So this will be our answer. This is the clear view of this example. You guys can take a look at it. So now let us learn limit of a polynomial function. Let's say we have a polynomial function f of x equal x squared plus bx plus c, right? You can have any polynomial function, it doesn't matter. This is an example where a, b, c, all of them are real number, okay? Now let's say x approaching to d. Remember d is also real number of f of x. It's going to be simply f of d. That's mean you just have to plug in d values in f function, like a linear function, all right? So as long as it is a real number, d is a real number. So you have if you plug in d here instead of x, you just write down d, right? So here ad squared bd plus c. So let's look at an example that will give us clear view of our concept. So let's say we have f of x equal 3x squared plus 2x plus 5, right? So x approaching to 1, this is 1 is a real number, so we can just simply write it down. X approaching to 1, f of x is just simply f of 1. This means we have to plug in 1 in here, right? So let's plug in 1 in here. So you have 3 times 1 squared plus 2 times 1 plus 5, right? So it's gonna give us 3 plus 2 plus 5, which is 10. So this will be our answer. You guys can take a look at here. We have a detailed view of this example. Now, let's talk about limit of a rational function. Let's say we have a function f of x equal x plus b, g of x equals cx plus d. It doesn't matter, f of x and g of x can be any function. Then a rational function p of x is going to be simply f of x over g of x, right? Now here a, b, c, d, all of them real number, okay? Now if limit x approaching to k of p of x for this function, right, and k is real number, then we can just simply write down this one is just f of k over g of k, right? And also g of k cannot be 0, okay? That will give us undefined value, right? So let's look at an example that will clear our concept. So let's say we have p of x, we have 3x plus 5 over 2x plus 3. So this is a rational function. Treat is a f of x and treat this one as a g of x. Now here x approaching to 1, that's mean limit x approaching to 1 and p of x. Think about 1 as a k. So we know if it's a k, then it's going to be simply f of k over g of k, right? That's mean we just have to plug in k values in f function and g function. But here we have 1, right? K is 1. So we can just simply write down 3 times 1 plus 5. We plugged in 1 in the top function and 2 times 1 plus 3 in the denominator, right? So 3 plus 1 is just 3 times 1 is just 3 plus 5, right? And 2 times 1 is just 2 plus 3. We have 3 here. So it's a 8 over 5. You see, denominator is not 0. So this function is defined, right? So this is our answer, 8 over 5. this is the clear version of our example. You guys can take a look at here also. 5 is not 0, right? Thank you guys.